Welcome to Geometry, Lesson 11.5b, more about lengths, areas, and volumes of similar figures. So, our next theorem, Theorem 11.5.3, the ratio of the areas of similar polygons is equal to the square of the ratio of the lengths of the corresponding sides. So up until this point, we've been contrasting sides in our proportions. Now what we're going to do is contrast the scale factor, or what k equals, the fraction that we've been solving for in each one of these problems, to the area of two figures. So if triangle ABC is similar to triangle DEF, we know that these sides are proportional. So we have no value here, but we know that x is to y. So x is to y is our scale factor. And then we can set the larger triangle over the smaller triangle. And we can set the side length we know over which is x for the larger triangle, over the side length of the smaller triangle, which is y. They're corresponding sides, but instead of just leaving it xy, we will now have it xy squared, and that's because we're doing area, and our answers will always be in squares. So as an example, it says find the perimeter and the area of this parallelogram JKLM if similar parallelogram TUVW has a perimeter of 66 and an area of 216 centimeters squared. So I wrote those values inside of this parallelogram. They've done all the work for you. You didn't have to find out what the area and perimeter were. But one of the things we have to look at is what is our scale factor. So let's look at the larger figure here, and it has side length LM, which is 20, and compare that to the smaller figure with the same side length is 15. So our scale factor is 20/15, or when reduced, 4/3. So the constant K, or the scale factor, is 4/3. So that's the first thing you will find. You'll use the corresponding sides to find the larger to smaller similarity ratio, which is your scale factor. So for these problems, you'll use large to small. So now that we have our ratio, we can now take our two parallelograms, and we'll put the larger parallelogram on the top, which we don't have a value for yet. We'll just call it the perimeter of JKLM over the perimeter of the smaller parallelogram, and that's over 66, and it will equal our ratio. Now with these, do not take, when you cross multiply, do not cross multiply the 3 times this figure. Merely place the figure equals to and multiply 66 centimeter by 4/3. I know this, you're going to go, well, why do you do that? That's actually the second step when we usually cross multiply. Just go straight there. So we now solve for the perimeter of our larger figure, and it's 4/3 times 66 centimeters, which is 88 centimeters. And now that we have the perimeter, we can solve for area. We have the area of JKLM, and it's being compared to the area of the other parallelogram, which is 216 centimeters squared, and we'll multiply 216 by, and we've squared this number. 4 squared is 16, 3 squared is 9, and we end up with 384 centimeters squared. So first step, find the ratio. Second step, compare the ratio to the perimeters and solve. And then the third step, compare the ratio to the areas and solve. Theorem 11.5.4, the ratio of the volumes of similar solids is equal to the cube of the ratio of corresponding triangles. You won't have too many problems like this, but the ratio of the volumes of the cubes is 2/5 cubed. The 2/5 comes from taking 4/10 and reducing it to 2/5 and cubing it, and this is what our ratio is, 8/125. For an example, you would take homework example 23, has us solve for surface area and for volume. The surface area is already, the essentials are already given. Surface area equals 360 millimeters squared. So it will be the surface area of the smaller pyramid compared to the surface area that's given of the larger one. So S/360, and that equals the comparison of the side lengths, or our ratios, which is 5 millimeters squared over 10 millimeters squared. And what we have then is S times 10 squared equals 360 times 5 squared. That is 100 S equals 9,000, and the surface area equals 90 millimeters squared. When you're solving for volume, very similar equation, except that you'll have volume on top. So you're doing the volume of the smaller pyramid, comparing it to the volume that's given for the larger one, and then you'll set up your side ratio, except the side ratios will be cubed, and your answer will be 50 millimeters cubed. Here's another example. Find RT if triangle MOP is similar to RAG. So RT is this piece right here, and you can see we have a situation where we're dropping a median that has divided the base by 2 on both of these, and we have a ratio of 10 to 8. So RT over 10, which is the comparison side, will equal the ratio 10 over 8. Cross multiply and your RT will equal 12.5. Another exercise, find OD if these two triangles are congruent. And we can see that we have side lengths that we can form a ratio with. And OD is this line in the middle of the triangle. And it also has a value for one of them. So if we solve for OD, we're going to use this piece OD over its own side length. And we'll use the piece 6 that compares to OD over its side length, GA, which is the corresponding side to OP. And if we multiply across, OD equals 8. Now you're saying, how can I remember all of these things? You don't have to remember all these things. What you have to remember is if you have two triangles that are similar to each other, you can take any pieces that are corresponding, and as long as you have a ratio, you can solve. So this is an example. Every part of this triangle can be solved whenever you have a ratio and at least one other value. So your homework is numbers 1 through 6. If you have any questions, be sure to contact me, and hope this helps.